Exciting, fascinating chemistry. We're looking at nuclear detectors. Detectors are devices used to identify and measure the presence of radiation. Now, there are several types of detector. The first is called electroscope. Electroscope is the simplest of all detecting devices. Basically, what we have is charged particles build up on metal foil. And as their metal foil builds up, they repel each other. Advantage of it, it's very simple and very cheap. Disadvantage, particle identification exact amounts cannot be it. So you don't know if it's an alpha, a beta. Remember, those do affect us differently. You also don't know the exact amount because it just, is it far apart or not at all? All right. Second type is a film badge. This is often used in many reactive plants. Photosensitive material is covered with a light-resistant substance. Advantage and disadvantage of some electroscope, it just basically tells, have you been exposed? All right, third type, it's called a Geiger counter. Now, our Geiger counter is a detector containing argon gas, completes the circuit as the charged particles enter. It's basically like a smoke detector, okay? Advantage, relatively inexpensive, a couple $100. Mobile and measurable, and the amount of radiation can be identified. Disadvantage, specific type, I don't know if it's alpha, I don't know if it's beta, I just know that's E type of radiation. Okay, last types are chamber devices. Most sophisticated detection devices. They use a volatile liquid or compressed gas to view particles. Advantage, types, and amount of radiation can be determined. Disadvantage, and not always very mobile, and they can be expensive, potential explosive. The chart above us is what we refer to as a cloud chamber, and the one down here is referred to as a bubble chamber. All right, uses of radiation. Okay, we have three different uses: tracers, medical treatment, and food preservation. All right, so tracers. Either trace can be vascular, so something like a CAT scan or nuclear medicine, we inject the radiation into the tissue so that we can see it around the heart. We can see the heart tissue. And the second is industrial examples. So what we do there is we put radioactive material into samples and then take x-rays to see if it's even and lacking stresses. Okay, second, medical treatment. We can have x-rays. X-rays don't penetrate metals, and since our bones contain calcium, they leave the photoplate unexposed and we can see where the bones are. Second type is cancer treatment. Now, that could be one of two types. Either it can be a direct placement, or where we're localized cancer treatment. We zap basically radiation onto the surface, or we can do chemotherapy, where the actual radioactive material is put into an IV and runs the entire system. Okay? All right, last one, radiation for the controversy. Pro, it preserves and protects food from a whole lot longer. We use that at NASA. Disadvantage, it's radiation, and it causes some people to get upset and concerned. Basically, that's it. We're done. Take care. Any problems, let me know. Bye.